you had sharing on earlier. Did you want to share?
I will eventually here. So what I've been doing, let's see, what did I start with? So several weeks ago, I wanted to read more things out of my robot, because Al was talking about how do you calibrate the steering and how do you get the steering to do what it's supposed to. And I kept saying, well, you got to just take the steering angle out of tab planner and scale that so your steering works. But I kept thinking, well, how do you know that it's working? And there's various things you can do. You can go out, you can drive in a circle, take a tape measure, measure the whole thing. Or there's got to be ways, fairly easy ways to get this information out of the robot itself. So I was thinking, well, you can look at it with GPS and look at your plot, or you can, I got various sensors. And one of the things that ROS generates, if you have wheel odometry, it will generate a rotational velocity to tell you how fast the vehicle is turning. And the standard in ROS, when they do their planners, they put out a forward velocity and a rotational velocity as a standard way to control things. So my reasoning was, if I were to put in a rotational velocity and then have some way to measure if it's doing the same thing, then you could scale it up and down until those two match. So I started thinking about what are my sources of rotational velocity, and my wheel odometry generates that. And I figured I could get it out of the GPS if I play with it long enough. And then the other thing was, any of the IMUs that have a gyroscope built in, the gyroscope is directly reporting rotational velocity. That's its whole purpose in life. So I was playing with that. I got my Razor IMU bolted down to the thing. Let's see if I go here. So I gotta wait for the one to show up. On my robot in the back here, over on the left, this is the Razor SparkFun Razor IMU screwed down to the top, and it's not right over baselink. It turns out neither my antenna nor my GPS or my IMU is directly over baselink, which is here. The axle on the back runs across about here. It's kind of a weird thing. So in reality, it's probably baselink is probably right about here. And so IMU is a little bit behind it, and I just wasn't looking close enough. I could have put it anywhere there, but when I put it on, I just wasn't paying attention. I just screwed it down there, and the GPS antenna is like maybe 4 inches or so behind baselink. And then on the front is my new one that I'll get to, and then my other antenna is on the front here that actually sticks out a little beyond the front. And GPS tells me those are 75 centimeters apart. If I pull out a tape measure, measure it, sure enough, they are 75 centimeters apart on the two antennas. So let's see, so anyway, I wanted to be able to measure all the rotational velocity off all these different sensors. So the one for the SparkFun Razor, they give you what they call sample code when you buy the thing and you load it in, and it just puts out, one of the options is put out all the raw value of all the sensors. So it'll put out accelerometers and gyroscopes and magnetometers. You can print out you can either print out the actual A to D counts for each one of those, or you hit a key and it switches over and gives you the scaled values. So it gives you the accelerometer in G's, and it gives you the gyroscope in it was either radians per second. No, that one I think is in degrees per second coming out of that. And then the magnetometer gives you like microtesla or millitesla or something. So anyway, it just dumps these out over the serial port. So I just had a ROS node that will read in that string of data, parse off the field that I wanted, and then publish that. And now that right now that I'm talking about it, I'll point out, if you publish a string and save it to a bag file and then pull up Plotjuggler does not understand a string at all. It doesn't even show up on the list. So even though I had, a whole bunch of values I could look at, Plotjuggler totally refused to do anything with that. So my options were, I've got some programs that I found that will take a bag file and break it down into multiple CSV files. So for every topic in there, it generates a file with your CSV values in there. So I can do it that way. So I can still put out the string and then break that down into, once I get the string, then load that into Excel or OpenOffice Calc and look at the values that way. So that does work, but by doing that, Plotjuggler is smart enough. It takes all of the different topics and lines them up in time, whereas Excel doesn't do that. Excel looks at the number of samples you have. So considering my GPS runs at 5 samples a second, and I think my odometry and my IMU stuff I'm doing, I think all runs at 10 samples a second. So one is twice as big when you try to plot that. So that doesn't work out well. So when I finally decided that I went into my ROS node for the IMU, and instead of having a string with 3 values in it, because I was looking at the 3 rotational velocities, I just parsed off the one number I wanted and plotted that as a float 32. So now I've got a topic. I called it razor or IMU or whatever I called it. It just puts out a single number that's a float 32, and then Plotjuggler can understand that and pull it in and look at that. And I guess, well, when I show my graphs, I'll show what the output of that looks like. So, and then I looked at the GPS and decided, well, how can I get the rotational velocity out of that? So by definition, rotational velocity is simply say, here's my heading right now, and my last time period is a different heading. So the difference between those 2 headings is how far I moved, how far I rotated in that time unit. So if I was measuring those once a second, and I read one, it says I'm at 0 degrees, the next one says I'm at 10 degrees, the next says I'm at 20 degrees. Well, by definition, I'm turning at 10 degrees per second. So I basically just went into, I pulled up one of the messages off my GPS. I'm using that nav rel pos ned message from the dual antenna moving baseline system. So it gives me my static heading. And I just took those numbers and said, just like I said, I just took each sample, and then each sample I said, how far did I rotate? And then based on the time unit, and since I'm doing five samples a second, I think I had to multiply it by 5 to get it. Either I had to multiply by 5 or divide by 5 or whatever. So now I had 3 different devices giving me rotational velocity. And with enough playing around, I got it where I could plot those on top of each other. I guess I won't show you on that graph unless I have a saved one. I put that on the Slack channel somewhere where I finally got to the point where I got all 3 of those sensors running at the same time and plot them on top of each other, and they all look relatively close. So now my reasoning was, now that I can do that, if I go back and say, generate a ROS command line message that says, move forward at 1 meter per second and rotate left at 1 radian per second, then run that through that TEB planner conversion module that they give you, and that will put out a steering angle. So I just have to scale that steering angle to my steering, and then whatever rotational velocity I put in should come back out on all 3 of those other sensors I have. So once I get to that point, then I can just tweak that number up and down to finally calibrate it so it comes out the way that I want. And then in all the talk, I was saying I was doing the stuff with the IMU, and then Al says, oh, I've got a whole box of IMUs. And one of them was the one from Adafruit. That's the fairly new BNO 085 sensor. And I thought, hey, I've got one of those. And I looked through my box, and I've actually got one of those. I got a sensor wired up to a Teensy 3.2 with somebody's code on that I was playing with a long time ago. And Javier says, oh, I've got a sensor that I use. And it turns out, I didn't realize until just yesterday that we've got 2 different types of sensors. Al has the 085 and Javier has the 055. And when I look at mine is the 055. So 2 of them are older than what Al has right now, but they do seem to work. And apparently they work the same way because the libraries seem to be labeled as the 08X, and I'm running the 055, and the code that Javier posted looks like he started with the same code I did. So apparently they're all the same type of thing. So I went down a whole rabbit hole trying to get this stuff to work. First of all, when I fired up my Teensy and my 055 sensor, it was putting data out on the, if I just do the Arduino serial plot, or not the serial monitor, I could see the values coming out there. But then when I load in the Arduino code that's supposed to run on an Arduino, it would not run, and I couldn't figure out why. And I realized that I'm using different I2C pins on the Teensy than it uses on the original Arduino. And I was assuming that there was something in the code that would specify which pins to use for that. So I wasted a couple days on that, and finally I realized, no, it's just based on the board itself, that whatever the pins on the processor for I2C are, those are the ones you must use. And to confuse matters on the this probably isn't going to work, but this
No, it's
that's the little card that comes with the Teensy when you buy it, and they say that up here you've got these two blue ones here. One says I2C 0, and the other one says, they both say 0. So apparently one is the normal pins, and the other two are the alternate pins you can use. And it turns out I was plugged into the wrong pair of pins, because when I was running this other code, they used the for some reason, people like to rewrite the I2C drivers. So you have the standard ones from Arduino, and then I think Adafruit has written their own I2C routines that apparently work the same way. And then the people at Teensy, or for the Teensy, somebody wrote one called I2C underbar T3, and I'm not sure why it's named that, or why you need it, but that was something different. So that one I think I was using that library on this other code, and it was using the alternate set of pins. And then it was, so I just moved the wires over four pins and ran the Adafruit code. Then all of a sudden I talked to the thing. So I was pretty happy that I can take off the shelf Adafruit code and put on this thing and talk to it. So I decided, what am I going to do with it? So I ran the one that's called a demo called read all data, and I just loaded that and fired it up, and sure enough, it was putting out it was putting out a whole bunch of values. There might be more values there that you could get to, and just, visually looking on the screen, it presents it in a nice block of data so you can see what's going on. So I thought, well, how am I going to get that into ROS in order to do something with it? So I took their code and fought with it for a while. It looks like it's written by a professional programmer, so it was hard to figure out. They load stuff into structures, and then they pass a structure to something and then print it out. And so I just went through and just reasoned out, if I take this print statement and change all the stuff that says X equals something, I just changed that to a comma, and then I let it print out all the blocks. I took out all the print lines. So by the time I was done, I got this one big long line that had 22 fields in it that were separated by commas. And later I realized that's around 100 characters, because when I was trying to get it, when I had problems getting to talk to Ubuntu, it was printing out that it was over 100 characters long. So it prints that data out over the serial port like you would expect. And so if I fire up the Arduino serial monitor and look at it, sure enough, it just prints out lines of text as the thing runs. So that, okay, now I'm all set. I'll just move it over to my robot computer, which is the Ubuntu 1604. And I started off, I went in and changed my UDEV rule, because I've got an extra port on a USB hub that I'm plugging into. So I set up the UDEV rule for that. And I tried running, I had the usual thing with permissions on serial ports. I fought with that, and I kept saying that it has to work. I added myself to dial-out group, or whatever it's called, and then I'd change the permissions on the port, and it would work. Next time I come back, the permissions were changed back to normal. It wouldn't let me talk to it, and I kept going back. This web page says, no, you don't have to do it. You just add your user to the dial-out group, and it'll take care of it. And after about the third time I looked at that page, magically it started working, and I don't know why. I don't know why that is. But anyway, I can plug that in. It recognizes it, actually, the UDEV rule recognizes that and renames it to something like TTY BNO 085 or whatever I called it. And then I tried to connect to it, and for some reason it would, like, say if I just say cat on that port, it would all of a sudden, blam, it put up a whole block of stuff. It put up like 5 lines of text, these big long lines. You put like 5 lines of text and just lock up. And if I run this under Windows on the Arduino serial monitor, it would come up and it would just put the lines out, put out a line, and 1 second later put out the next line, and so forth. It just put them out at a normal rate like it's supposed to do. But for some reason, the Teensy 3.2 under Ubuntu does not want to play. I think what happens is you plug the thing in, the thing starts up and starts outputting data. And since nobody's at the other end of the USB listening, I think it just fills up the buffer and sitting there waiting for something to happen. So as soon as you initialize the port under Ubuntu, it says, oh, there's data. It goes, bam, it just pulls in the whole block of stuff and slams it on the screen. And then it's locked up because I think it overwrote something in the Teensy. So that took me another day or so to figure that one out. And if I went out to the Teensy website they're talking about the serial driver. And so basically it's the Arduino serial driver, but it's for Teensy. And I dug down through there, and there's something called serial. So you say if serial, and it's actually checking the state of the port to see if the port has been opened or not. And theoretically, it says it's supposed to wait. So you say initialize the serial port and then wait for the port to be active before you do anything else. And it seemed reasonable. So I tried that, but it didn't seem to work. It looked like it was under again, on the Windows computer, it did look like it was working because I could start it up and watch the screen and nothing was happening. No, that's not true. And anyway, the bottom line is that if serial was not working. So I looked at it some more and kept thinking there's got to be some way to make that work. And I went down about another page in that documentation that says, oh, you can also check the DTR status. So there's another one that says something like if DTR, then you say, while DTR, you sit and wait. So that does like what I expected the first one to do. So when you start up the code, it initializes the serial port and it sits and waits to see that the other end is ready. And they added a couple extra lines. One says initialize the LED, and when you first reset the thing, the LED comes on. And then when you come over here later to Ubuntu and say start up, say Minicom, which is a serial program, or I start up my ROS driver, then the LED goes off and then the thing starts outputting the data. And that fixed my problem. So as long as the very first time it will work, but if for some reason I shut down my terminal program under Ubuntu and start it up again, I think I'm going to have the same problem. It's going to do something stupid and be locked up. So I might be able to move that code down to where it says generate the line of data from my device, and just before I print it, and then put that line in there. So it says if for some reason the interface is not active, just sit and wait for it to become active. And then I think that way that would get me around trying to, in the future, because you start testing and you have to get all these steps just right. You got to plug that thing in and then make sure you don't do anything until you're ready to go, and you start your launch file. It opens that port and it should start working. But there's always things where you start stuff up and shut it down, and it's going to come back to bite you if it doesn't automatically take care of itself. So I'll have to play with that a little more later to get that figured out. And since I got Al on the line here, do you recall having any problems getting your Teensy 3.2 to talk to Ubuntu? And by the way, it does this both on Ubuntu 16.04 and 20.04. It acts exactly the same way. So I just wonder if you've got anything in your code that takes care of that.
I'm just looking at my, not any kind of problems like you described. I'm just going back through my, not when I was directly connected to the computer, no. I mean, either with Windows or, I mean, I'm just share my screen. I'm just paging through my instructions here. My only issues was when I was trying to remote program it through Platform IO. But, you know, pressing that, I mean, I'm assuming you went through that, having to press that manual program button, right?
I don't have any problems with that. Oh, and that answers another question. That's not a reset button. That's a manual program button. 'Cause I noticed that when I push the button on the board, I expected it to reset the thing and restart it, and it didn't. So I had to unplug the cable and plug it back in, due to my testing here. But that answers the question. That's a manual program button and not a reset button, and that explains why it doesn't reset when I press it.
I mean, I think officially it's called the Teensy loader application button.
Okay, well that answers the other question that I forgot about until you just brought that up. That yeah, don't expect that to be a reset button because apparently it's not. But no, I think the very first time you run it, you might have to press that and do it, and then I think after that it always takes care of itself. So no, I haven't done anything with that for forever, other than that little box shows up every time I start the programmer. So.
That's why I write stuff down. Pardon my coarseness.
While you're right there, can you post the link to that page to the chat? Since I can never seem to find this stuff, I knew this stuff was all out there, but I had no idea where it's at, and I don't know if I have access to it or not. So we'll find out.
Well, and again, on the top of it, you're going to see a lot about Platform IO because originally it was written with that in mind, but yeah.
I know you've got pieces of code posted around places too, and some of it's on that gist, and some of it's probably on here. And I would have just looked at your code, but I didn't know how to find it. So, but I know you use a lot of Teensy, so I figured you would either run into this problem or maybe because the first problem I had was it popped up and it was complaining. If I looked at D message, it was saying there's something about some funny things with the USB port, and I copied that out and went looking for it. I found this thing that was like 45 pages long of people saying, well, I've got this problem from my USB port, and here's the error. And after like 45 pages, they said, well, possibly if you update your kernel to something newer. But I finally decided that probably was not my problem, because one computer is 1604 and one's 2004. So the one on 2004, but I guess I don't know that I had the error on 2004. I don't know if I was looking at that point. But anyway, after I got done with that error seemed to go away, and then I had this other problem where it just simply seemed to buffer up everything. And as soon as I initialized it, blasted out, and then everything's locked up. So I was just trying to get around that.
What IDE are you using?
Well, for the program, I'm just using the standard Arduino IDE with the Teensy extensions to it. So that's how I program the thing.
Wow, and you're getting the kernel needs to be upgraded error? That seems
well.
Wow.
No, this is when I then take the board and plug it into Ubuntu. So now I'm moving it to a different machine. Then that's where my IO problem is, in between the two, and it's saying, oh, you might have to update your kernel. But they were talking about like other like Wi-Fi modules, and they said they saw this on multiple different types of modules. And but anyway, it turns out that had nothing to do with it apparently, because that all went away, and I moved on to this other stuff. So let's see, where was I? I was complaining about the Teensy not wanting to talk, and then after I put that thing in, then I could get it to work. And so now, as long as I do it in the right order, where I set it up in the front yard, and I plug in the one cable to the laptop that goes to the hub, and that powers up both USB or both GPS modules, and it powers up the Razer IMU, and now it powers up my new IMU I just put on there. And then as long as I do it in that order, then the little lights on my Teensy saying that it's waiting for something to happen. So then when I say start up the launch file under ROS, it initializes that port, the light on that Teensy goes off, and then it starts sending data like it's supposed to. So that as long as I follow that order, everything seems to be working, but I need to look at that a little harder one of these days. So anyway, I got at the point where I basically copied my ROS node that I was talking to the Razer IMU, and I took the data coming out of the new IMU, and just took the very first, I split the line and took the very first field and published that as a float 32, and then that shows up as the heading, because this device directly puts out heading because it's got a built-in processor and does all kinds of fun stuff for you. And I was able to plot that out as a ROS node or as a ROS topic, and then I can plot that and look at it later. So I've got the Razor IMU is publishing rotational velocity. The new one is publishing an actual heading. And if I want to, the rotational velocity comes out, and I could do something, which takes me down the next path. I was trying to think, if I use the original code that I started with, it puts out 22 values every time it does a sample. You know, how am I going to get that into ROS and in order to put that into a bag file? So that brings up the concept. You know, originally I would just publish it as a string because that's nice and easy. You just take that whole line that came in from your Arduino type device and publish that as a ROS topic as a string, but Plotjuggler does not like that. So my options are either take each field and publish each one of those separately, or I could, I think I can build an array. So you'd say, here's an array of float 32s, and then just populate all those with the values that came in. And then when it gets published as a ROS topic, it should show up as an array. And I think Plotjuggler might understand that, but I haven't got that far to figure out if it will or not. And then the other option is build a custom message that says, here's my IMU, and then list all the different types and fields and build a message and populate it that way. And I kept thinking, well, if I'm going to go to that trouble, I might as well just find an actual ROS driver to talk to one of these boards and go that path. So I started searching on that. And at one point you said, is it better to use the UART or the I2C interface? Well, I found out the answer to that because when I was digging through, I was looking for one that was a ROS driver that would connect to an Arduino type board like I'm doing right now, and take the data in and parse it and publish that. But what I found was one ROS driver says, oh, we'll connect directly to the I2C port and leave out the microcontroller. So they're connecting their board directly to a Raspberry Pi over the I2C. So they don't have an extra microcontroller in there. The ROS driver itself does everything your microcontroller would normally do. So that's one option right there. But since number one, I don't even have a Raspberry Pi on my thing right at the moment. And the other problem is I don't want to have a Raspberry Pi and my IMU with a magnetometer connected to it on a little short piece of wire to keep the noise down, because then you've got stuff with conflicts of, you know, where's it mounted on the machine. And if you put long wires so you can mount it somewhere else, then you run into noise problems on that. So I'm not really looking at that real hard anyway. And then the other option I found are ROS drivers, where it says it will talk to the UART on your little module. So basically what they do is they just take your little module and hook an FTDI adapter up to it and run the USB cable and plug it right into your Ubuntu computer. And this driver actually just talks over the UART to talk to the thing. And that way it leaves out a microcontroller, which costs you anywhere between $3 to $25. And apparently that's not needed at all, because the ROS driver is smart enough to generate the commands that will go over the UART, and then it send the data back over the UART, and everybody's happy with that. And I was thinking, well, I'll try that. I actually found one of my little adapters, and I realized the board that I have is it's a real little cheap piece of crap that it's got these two solder pads on the board that you have to put a solder blob. They're the two option bits that are on the thing. And I think the one that Al has, those actually come out on pins, so you can wire them normally. And the thing is, when I first started off, I took the solder off the things and later tried to put the solder back on. It turns out they didn't make them close together like you should. So you try to put solder on it. I couldn't get the solder blob to join the two pads together. And I thought, I don't want to screw around with that again. I've only got one board that works. I bought two of those boards, and one of them, I either burned it up or it didn't work when I got it. So I haven't tried that yet. But probably one of the cleanest options would be to find somebody's ROS driver and connect it to this module somehow, either directly over I2C or directly over the UART, or if I could find one that says connect to an Arduino type board in between the two, which I haven't found that yet. So I still have the option. I could take this line of 22 fields coming out and then just write my own driver that says, take the appropriate field there and plug it into whatever ROS topic I want. And I could populate the normal ROS messages. So they have one called IMU and one called IMU raw and one called temperature, and they got like 4 different messages for IMUs. I could just take my data and plug it into the appropriate fields. But that seemed like a lot of work to do that if I could just get somebody's driver and load it and run it. So that's kind of where I'm at right now, the point where I do have it running where I just read, I turn it on and it puts out the heading, and I can publish that as a ROS topic. I can write that to a bag file and then come back later and play that back. So before we move on to the graphs and all that stuff, I'll go back to the pictures here again if I can make this work. So this was on the top of my robot. So I already had the SparkFun Razor IMU in the back here. And then here's the new one. It's just a proto board. It's got a Teensy 3.2. That didn't work. There we go. Okay, so here's on the front, there's just it's a Teensy 3.2, and you can see the LEDs on, which means I haven't started talking to it yet. And this particular cable's got a blue light in it just to be cute, I guess. And here's my module. It's just a little tiny module. And maybe I think these are the solder blobs there. I think I got a better picture of it here. But all I just simply found a place that it would fit. I have to leave this spot open because when I started, I lay my laptop right here before I shove it in the hole down here. So the laptop's laying there. I wanted open space there. And I figured where it's mounted there isn't real close to any large metal objects. This GPS antenna might have some metal in it. This laser scanner down below it is mostly aluminum, but it might have some steel in it. So I basically just wanted to get it on there to verify, is it going to work at all? So I've just got it on. The USB cable goes under the Velcro strap that's there to hold the GPS cable. And then I just took one of those big rubber bands and that's just a single rubber band. I just put it around my finger in one spot and then just wrap the rubber band around the bottom where they came back together. I just put a piece of wire to tie the two together, and that's all that's holding it down. So if it wants to, it can slide around a little bit, and you can see it's not exactly parallel to this board right there. But I just wanted to say, can I get the values out, and do they look at all close? Previously, when I played with IMUs and you try to look at the heading, you might get a heading, but it's going to be pointing in the wrong direction. You sit there watching it, it's going to drift one direction or the other. And just on the table, this one seemed to be fairly stable. So I was fairly happy with that. And I got a couple more pictures here. This is just a close-up of the same mounting we just had. So we zoom in and look here. Well, I guess here's one of the solder blobs. I guess the rubber band's got it covered up, but they're a real pain to use. Since they're far enough apart, you either have to put a ton of solder on, and solder likes to stick to one pad or the other, so you can't get the blob to join the two. So I think I finally ended up just cutting a piece of wire, a little tiny wire, and soldering across the two to get them to work. But I've screwed this board up enough. I didn't want to attack that again because I may destroy it completely where it won't run at all. So I haven't tried the UART option on that yet. And then I guess just here's just a top view of the same thing. And this gray thing right there, that's a piece of wood that's painted gray. And then here going across here is my roll bar with again is just made out of wood, the black vertical pieces, and a piece going across. It's actually a single bolt here that bolts the top rail onto that roll bar. So that's a piece of steel there that could theoretically screw things up. But again, I just wanted to see, will it work at all? And then this just on the back, here's my Razor IMU, and it's just connected down. I just got some just 4 screws. I just drilled holes into the wood and put these screws in. I think they were called sheet metal screws, like a number 4 sheet metal screw. So it's just screwed down. And if I look at it, I decided that's not quite square either, but since the only thing I was trying to do is get the rotational velocity out of this one, so I didn't really care. I didn't care about the magnetic field. I didn't care if it's lined up with any particular axis, because if I'm just rotating the rotational velocity, I could have mounted it at any angle I want, and that would have still worked. So I think I got one more picture. I think it's just the side view. So basically, here's the side. Here's that I was talking about, the roll bar in the front, this black thing, and then this gray thing is just a piece of wood. I don't know if it's pine or what it was. It's just something I bought at the lumber yard, and I just painted that black with spray paint. So here again, here's the Razor IMU in the back, and here's the new IMU hooked on with just a rubber band, and you can see the relationship to the 2 GPS antennas. And again, as far as big blocks of steel, well, the laptop would probably affect the magnetic field. The antenna might. This big laser scanner might. But other than that, it's fairly open around there for 8 to 12 inches or whatever. But I still didn't know if that was going to solve my problems or not. Let me try my other computers and get this to work. Select screen. Plotjuggler. Go. Well, what's nice about having 2 computers running here, I can see that number one, it hasn't shown up yet, so we'll give it time. For some reason, the fancy computer, the 2004, doesn't seem to want to respond very quickly. So this is, I went out in the front yard and drove around here. Let me see. I went out in the front yard, and the plot on the left here, this is latitude and longitude, and I think I had to flip the X and the Y to get it. So this line here is running north and south. And then the output of this one is the output from that GPS odom. It's something that Matt wrote. And this one, I don't have to flip the axes, but this subtracts off my 0, 0. My 0, 0 is actually right there where this thing is, where the X is right now. That was just some arbitrary number. When I started playing with this, I said, oh, I have to have a GPS offset. So I just pulled up something that was, I started a bag file, whatever it told me, I just put that value in. So apparently that value was right there in the center of my yard. And I need to come down, if I come down here somewhere where my sidewalk, the junction of my sidewalk, I should mark that point and say that will be my my GPS origin. But for right now, it's just, again, it's, if I look at the right screen, this would help. So anyway, that's 0, 0 if you look at the graph, and that's my origin. So anyway, I just stand in the front yard. I put the robot right here, I just pointed it north, just by looking at it, it looked like it's north. Looking at the graph, that doesn't look like it's going exactly north. But anyway, I started right there. And by pointing it north, that means when my odometry comes up, it'll think it's pointed north, because it always starts at 0, 0, 0, X 0, Y 0, and a theta of 0. And that way, that's just a quick trick to keep the odometry happy. But for some reason, I didn't get odometry this time I ran it. So I think there was some error about the communication to the microcontroller didn't like the first byte, and therefore it didn't start that driver. So I didn't get any odometry information. But you'll see as I go through, I do get a lot of information when I run this. So I pointed it north, and that keeps the odometry happy if it would have worked. And then it turns out when you start the driver for this new IMU, it always says you are pointed 0 degrees. It always thinks you're pointed north, no matter what direction it's pointed. And as you move it around a little bit, it does some kind of fancy magnetic calibration, and all of a sudden it locks in, and then it does point north. So that got me around that problem too. I need to go out and check that to see if I pointed it, say 23 degrees, and start it, and this drive around in a circle, does it automatically lock on? So it's got the correct heading, but I'll have to get into that. So anyway, I started there and started recording the heading, and basically I just drove around. In fact, we can watch it drive around here. So I started right here. That little dot right there shows, wrong screen again. So anyway, that little dot right there is where the robot is sitting. And what it'll happen, you'll see I'll drive forward to this point and pause. I turn the wheels to the left, I drive around here and come back and pause. And then turn the wheels right and drive around and pause. I got there and thought, well, I paused again because I, well, what am I going to do now? So I just went and drove in a straight line. So I should have been driving north. And I come up and I just go around the loop here and come back here and stop. So if I drag this little slider down here, you can see that, see, I started moving forward, it comes here, it pauses there, and then I drive around. I guess you can't see it pause because of the way I'm dragging. If I put it on autoplay here, you can see that. But see, I come around here and then I drive up here, I turn right out here onto the sidewalk, and I drive south down the sidewalk. And then, okay, drive back into the grass, and then I just kind of randomly drove back. I got right about here. I thought, well, what am I going to do now? I thought, well, I'll just try to line it up north again. I finished driving until I got there and stopped. So that's what the path looks like. And the one on the left, this is the path directly out of GPS and latitude and longitude. The one on the right is the output of Matt's GPS ODOM program that subtracts off a latitude and longitude offset and converts it to meters. And that seems to be working. And so if I go look here.
And all of that is joystick control.
Yes, I was just driving around with my remote control joystick and it's talking directly to the microcontroller. So it's bypassing ROS completely. But I just have, a joystick I can move forward and backward and left and right. And that's really all that was doing. So in this one, the bottom line, this is my...
and the joystick is issuing command velocity.
My joystick is simply putting out plus and minus 128 in either axis. I send that over to the robot. The robot just blatantly scales that to kind of like the way yours is set up, where you take plus and minus 1 and you set max left and right. Well, mine is saying max left and right is based on plus and minus 128. And then for the velocity, I actually put in a scale factor for the velocity. So it, I don't remember how I scaled that. I did find out by accident that I can drive over 2 meters per second from that one plot I was showing where I was going in the circle and my tires are slipping. And I looked at it and it said I was going I was going 2 meters per second at that point, which is awfully fast. So on this plot, this is out of the bottom plot is out of my static heading from my moving baseline. So I got the dual antenna system. It takes the front antenna, compares to the back antenna, and tells you your angle you're driving at and whether I'm moving or not. So I start here, and when I first turn it on, it thinks I'm pointed 0, which, because I lined the robot up to point north to start with. So it's coming along here at 0. And then when I start moving, you can see it jumps up here. And as I'm going around the circle, you'll see that it's the heading is going from 360, and it's coming back down and gets down. As I finish off the circle, I'm back down to an angle of 0 again, and I turn the wheels to the right and come back up. And I go all the way around the circle to stop again. I'm back to 360, and I start moving straight north, and then it rolls over just a little bit. And then as I'm driving here, right here, I'm stopped, and right here, I'm driving. And then as I turn right, you can see the heading changes, and then I drive to the right, which is east. And then I turn again to drive on the sidewalk, so you see the heading change. And here I am driving south down the sidewalk. And again, I turn right. And then here I'm driving across, just kind of a random thing to go across. And then on top, this is the output of the news with banging. I see it's paused here. Hold on. Okay, so at the beginning here, we start off, since I pointed this thing north and initialized it, it thought it was 0 degrees. It always thinks it's 0 degrees, but since I lined the two up, that it's happy about that. And as I drive along here, I come along, and then it's doing this bouncing up and down, and that's just simply the noise between 0 degrees and 360 degrees. So even though it looks like it's a problem, it's really not. And then I come over here, and again, it's doing the same thing, where again, it's just, I'm so close to 0 degrees, a little bit of noise is making it bounce back and forth. And when we look in the next plot, you'll see I was actually moving right here, and that's why there's extra noise right there. And you can't really see it on the bottom one here, but I think if you zoom in, you can see there's just a little bit of jitter on that, just due to the fact that that's where I was driving forward. I started and I drove forward a couple of feet to the center of my circle, and that's what that's why this is extra noisy right there. And then when I actually started moving, you can see the top plot kind of matches the bottom plot, or it looks very close to the bottom plot. And anywhere where it's not doing this massive jumping up and down, everything looks very close to what it should be. Now, the problem is I can't plot these right on top of each other because the top plot right off the IMU goes from 0 to 360 degrees. Well, the one off the moving baseline goes from 0 to 3.6 million. So I can't plot those on top of each other. Now, if I knew more about Plotjuggler, I could probably say, take my plot and divide each point by 100,000, and that would put it back into the range of 0 to 360. But I haven't figured out how to do that. There's something you can create a custom series, and they've got like statistical things you can load. But I just want to say, no, just divide each point by 10,000. I haven't figured out how to do that yet. So if I can do that, then I can put this, my reference plot here, I can put that directly on top of the heading coming off the IMU, and see exactly how far off they are each time. But the fact that they came out looking at all the same, I'm extremely happy about that. That says that of any IMU I've used so far, this one's actually giving me real usable results. And I did no special calibration on this other than I stuck it down with a rubber band, pointed the vehicle roughly north, which probably isn't exactly north, although I'm off by whatever this says down here. This, because on the moving baseline, this should be the actual heading. And well, here, let's do this.
Do you think you were on RTK the whole time?
I assume I am, but once I put my receivers inside the box, I can't see the LEDs anymore. Now there are numbers coming out that I can look at that will tell me what my fix was, but I think I'm going to assume that yes, it was the entire time it was accurate. So this right here says I was at 242,000, which is probably 242 degrees. So right off, I was not at 0 degrees. I was not at 360 or 0. I was at 240 something, according to my moving baseline. If I come on, let's see, gonna go here. And like here when I'm moving, again, this says 320 degrees. So that accounts for the fact when we look at this line's not exactly going north because I just simply I didn't point the thing exactly north when I started, partly because I've done this so many times, I just get tired of all the little details. I said, okay, I put it there and it's roughly north. I just wanted to verify if the thing was running or not, and it does seem to be working. So in general, if you look at the plots out here and compare them to the plots down here, they look extremely close, and that probably will give you a good enough heading to do most of the things you want to do. And Javier says he's happy with what's coming out of his, and he's basically getting the same stuff on the top here, and he's using that as a heading, and then he uses the latitude and longitude as his position, and he feeds that into some other I don't know if it's the nav transform node or what he's using. He made I found on the RTK channel, he mentioned some stuff on that. I didn't know the RTK channel was actually being used until yesterday. I noticed there's something in there, so I went ahead and subscribed to it so I was reading his messages. He gives just a short description. He says he's using his IMU to get the heading, and he's using his GPS to get the XY, and then he does something with that. So that's what he's actually using right now. He's got a sensor just like the one I have, except it's on a different board. And the one Al has may work even better because it's a newer version of the same thing. So basically, if you load it up, it should be putting out a heading, and you can use that directly. So that would be good. So you don't have to try to extract the one out of the GPS, although you can compare it to your computed one out of the GPS. And while you're moving, you can compare the two to see if to see if it hasn't gone totally bad on you. So that would be a handy thing to use. So one other thing I did here was, of all the data I've got, if you look on the left here, these are all my topics that I have, and you probably won't be able to read this because they're so small. But the top one, it says, here's my my B&O 85 heading. So that's just a single value that plots the heading we're just looking at. And the diagnostics is something that the two GPS receivers publish this. And it's got lots of information that the driver publishes. And I can't even remember what's in there. I usually don't look at it because it doesn't seem to have my thing to tell me what kind of fix I have. And then under my GPS 0, which is my back GPS, it's publishing, here's your standard fix and your fix velocity. And one of those two, I think the fix gives the, here, let's just try this. Let's open a new tab and say fix on GPS 0 and status. I think it's this one, status. So it looks like the whole time it had a status of 2, which I assume means it has a fix the entire time. The one called service, I'm not sure what that one is. It was 1 the entire time. So those are 2 different things labeled status coming out of my first GPS receiver. And it looks like they were solid the entire time I was driving around. So then in fix, you get your normal latitude, longitude, altitude, and you get a covariance, which I assume works. I haven't actually tried to verify that. Then under fixed velocities, the standard, what do you call it? The velocity vector that you can use to extract out, you can extract the heading out of that if you want to. And I think down below, I'm actually doing that. And then here's, then the extra ones I have that the F9P puts out. There's one called nav heading. And I think that's publishing a quaternion. But here it has one called angular velocity. But I think when I looked at it, none of these are actually doing anything. I think they're all 0 the entire time. So at least nav heading for the first GPS isn't doing anything. And then there's one called nav pause ECEF. And that one is, it's latitude and longitude in a, come on. Huh, well, it's not gonna work. Oh, I know why. I already had a linear plot on there and I was trying to put a XY plot on top of it. So there we go. So this one puts out an actual offset in meters, probably from Greenwich, England, whatever the reference point for GPS is. And see, you get these big numbers of, what is that, like 4.5 million meters from wherever, and going around the other direction, it's like 2.5 million meters. So what you can do is, if I figure out an offset here, say go out and measure my sidewalk, if I take the X and Y offset in meters, or the XI point in meters, I can do the same thing by just, without using latitude and longitude at all, I can get, this thing puts out the meters. So it would say that, you know, before I had a point over here, it says 0, 0. Well, that would still be the same point if I did it the same way. So that's just another way to get information out of the GPS and not have to screw around with latitude and longitude. So I could convert this directly to offset in meters by subtracting off the offset. So it puts that out, and the nav PVT has all kinds of information in here. This one has ground speed, and it's got, here's a heading that it puts out. So if we put out this heading, so the headings all look the same, but they have slightly different, they may have different scales. And this one, see, is noisier. You can see it's got a lot of, just driving in a straight path here, you can see there's lots of noise on the thing. And what else do I have? Heading. Now you get the time in various ways. Here's the same latitude and longitude as in this message. Here's more stuff on the dates. So there's all kinds of stuff in here. I don't even know what it is, but that's something else I can easily get to and then go plot it later if I want to look at that. So that's all on the back GPS, and then the front GPS, I'm printing out again the fix and the fixed velocity and that nav heading we looked at. And the important one here is this nav rail pause NED message. And that's the one that has the moving baseline, which we saw somewhere else, but I'll say rail pause heading. Yeah, that is what I want. So that's the cleaned up one. So compared to say this one, which is just a, which one's that out of? Heading. That's the actual heading out of the back GPS. So it's not, has nothing to do with the moving baseline. And that's essentially the same heading you would get if you, on your NEMA message, where it says, here's your course over ground. This is probably the exact same thing there, except this one from the nav PVT, this one seems to latch it. So it's, so right here, I don't have, normally on the NEMA message, this would be all garbage coming out. And here it starts off this value as soon as I start to move. Again, this is the 0 to 360 jitter. But once it's moving, here I came to a stop and it latched it at that value. So this particular message does latch it, but I've noticed that if it latches at just the wrong time, it latches in the noise. And this is probably, this flat line right there probably should be down here at 0, and it's not. So again, that's just more stuff to consider. Are the things lying to you. And another thing I had here was in this particular message, it says, what's my my position length? And you notice it centers around 75. That says my two antennas are 75 centimeters apart, because it's keeping track of that. And anytime it goes off a long ways, that could potentially be an error condition. But most of the time it's centered around, it's 75 centimeters plus or minus 1 centimeter. So that's something else you could check that and validate if that's
Those
within the
are
right range or not.
centimeters.
Centimeters, yes. That's just simply the distance from my front antenna to my back antenna.
I mean, because that's like a 30 centimeter range. I mean, if you're driving a super tanker, that's nothing. But if you're driving a 1 meter robot, that's a big range.
It is, but you don't really, it's just something falls out of the calculations. So see how that, I'm going to say you should just ignore this, other than the fact it just verified that, yes, it's working because my two antennas are 75 centimeters apart. But yeah, you've got a point that on that. In fact, they say if you're running moving baseline, they recommend you don't go any shorter than 1 meter. And I am at 3/4 of a meter, simply because that's all the bigger my vehicle is. And I'm even stretched a little bit beyond the length of my vehicle.
Got it.
So this is the one. So the heading coming off this gives me a nice, beautiful heading. It's always
Yeah,
valid
that's
whether I'm moving or
fantastic.
not. And you can see I don't have all that extra noise jitter on here. So in general, but I was saying that thing that got latched, this probably should be at 0. Well, it turns out it's not at 0. 0 is down here. So that latched one may still be okay. But if you happen to have a dual antenna system, it works much better, but it does cost you twice as much to do that. So that's the drawback to that.
And how's the trees and stuff where you were testing?
I've got a house on one side and I've got one tree on the other side. And I say back, maybe I deleted that one. But anyway, it said it maintained the fix the entire time. So I noticed if I start it on either on my front step, which has a roof over it, or I think even there, it doesn't want to lock on. I have to actually move it out into the yard for it to get a valid RTK fix. So there are options like that. I want to get it so I'm better at getting it to drive around. I can actually go out and do testing, like say drive it by the trees or under the trees, or do something to make it drop out. And then other stuff I'm doing here. This heading, I think, comes out of that thing that Matt wrote that's called GPS heading, and it publishes a quaternion that supposedly can go into the localization node or something. So I basically took the stuff he has, which takes the does it actually take a heading? I think it takes the latitude and longitude and converts that into a heading, or it takes the fixed velocity message. I think it takes the fixed velocity message and converts that into a vector and then publishes that as a quaternion. So you can't view it unless possibly if you look at maybe somewhere in RViz to look at that. So anyway, that's something I'm creating by reading from the GPS node and generating that. And then here's the ones called gyro velocity. This actually is the Razor IMU. So that's coming off the Razor IMU off the yaw value from the gyroscope. So it's just the gyroscope, just raw output says I'm turning this many degrees per second. So I'm just grabbing that and publishing it. And then what's called GPS rotational velocity. Again, I got to get rid of these big spikes because that screws up everything. But if I zoom in here, just ignore the spikes. The spikes are due to that rollover between 0 and 360. So this is the recovered rotational velocity by reading the static baseline heading and converting that. Like I said, I take 1 point minus the last point, which tells me how far it rotated, and multiply that by the time unit. And you can see the rotational velocity coming out of the GPS and the rotational velocity coming out of the accelerometer end up on top of each other. So that, number one, that verifies that I knew what I was doing. And if I would have got odometry data, I could publish the odometry, the rotational velocity from the odometry, and it lines up on top of this too. Somewhere I did that, and I don't know if I posted that to Slack or not, but my 3 different versions of rotational velocity are all seem to be working. And then the other
What
thing I've
time
got here,
slice are you taking that at?
the GPS is at 5 hertz, and the IMU is probably at 10 hertz. And Plotjuggler is smart enough, it lines all that stuff up. And I'm not sure how they do that, but that's just a miracle they can do that. And I guess then the other thing I've got here, I'm running that GPS ODOM, which is the program Matt wrote that takes, I think it takes latitude and longitude and converts it. It subtracts off your origin and then converts it. I think we plotted that before, but plot it again. And there's, of course, there's always extra stuff in these that may be useful, but and plot that. So that's the one that's converted. It subtracts off my offset. Oh, see right there, that dot right there before I move anything, that says that's where my 0, 0 origin is. So it's subtracting that off from the latitude and longitude. And then it says, so I'm this far off from my origin. And that's just random because I haven't specified an origin yet. So that's the stuff I'm getting out of the GPS. So basically the GPS 0 has that stuff and GPS 1 has that stuff. And some of it's not really useful in one case. Usually, mainly the GPS 1, the front one, the nav-rel pos ned, which is my static baseline. That's really the only thing that's really useful, except for the fact when I say you can do like this, where I say, go to my GPS 0 fix, which is the one in the back, and say latitude and longitude, plot that, and then go to my GPS 1, which is the antenna in the front, and we look at latitude and longitude and plot those. You can see the difference between the front antenna and the back antenna. So when I'm driving in a straight line, that they both line up, they're on top of each other. But when I'm turning, the front one, which the blue one is the front antenna. So you're driving here. Let's see. So right here is where the blue one starts. So I'm driving a straight line here. Here, let's try this. So I'm driving a straight line here, and I think, anyways, I start to turn. This blue one is showing the front line, and this green one is showing the back line as I go around the circle. Then I get here and rotate the other direction. Well, now this blue one is the front of the robot, and then the green line is basically just the trailing. So the green line is also very close to base link. So you can say that the green is base link and the blue is just in front of the front axle. And I didn't know if that was going to show up or not when I first thought of this, but it turns out it does. You can actually see the difference between, the two are 75 centimeters apart, and as you turn, so the front one leads the back one as you go around. So there's just lots of extra information in here. And then there's a lot, there's like another 200 messages I could publish out of the GPS to do whatever I want, but you have to figure out what to do with them. So that's kind of where I'm at the moment. So I'm still back to the point, I got to figure out how to get the data out of the new IMU into something I can plot on Plotjuggler. And that's kind of where I'm at right now.
That's a lot.
Now I can't get back to my screen again. Here, what's this do? Ah,
You're still sharing, by the way.
yeah, I'm trying to figure out how to turn it off. There, I had to get everything out of the way so I can get back to the screen.
Well, just briefly, from my end, so as you mentioned, some time ago, I bought this thing, which is officially, that's the model number.
Do you recall, is that the price you paid for it? I was thinking that was $35 to start with, and now it says it's $19.95.
My recollection is, yeah, I probably paid a little bit more than that. Yeah, but
And the one that Javier has is also from Adafruit, and it's it is $35. It's the older 055 chip. I assuming the 55 is older than the 85, but that's just a guess on my part. But both of them are out of stock, so apparently they can't get the chips right now.
yeah, and I mean, if you read, I mean, these are the guys who make it for them, and I mean, they talk about, you know, they've put an ARM processor on top of this thing, so you know the performance is meant to be a lot more powerful, which, you know, I've not really been able to figure out yet. But so one of my path to understanding this thing has, as far as I've gotten, is I found this guy. This is in, you know, I put this out on my GIST hub so far, and this guy had posted some code. I've got it to work on mine. Actually, it's like super small program. I mean, I actually got it to work on an old Nano was 168p, which is the smaller version. And it just takes this library, which is evidently a newer version of that library, and it reads. The way this works is they have what they would call reports that you probe the board and ask it to, you know, provide a particular report. And this is the rotation vector report. And so you get the data based on that report. And it was a bit of a journey, but this is the reference manual for the chip, and this is the long list of reports that you can get for the board. The rotation vector is there. I think I want, and I could probably get rotational velocity by doing the calculation, because the quaternion comes with the gyroscope. I'm sorry, with the where's the 05 with the rotation vector.
What is it you're trying to get out of it? What would you like to get out of it?
Well, I want rotational velocity, right?
Well, if you want rotational velocity, but if you go back to that, you were just showing that list of them there, the one that's called gyroscope uncalibrated, that would give you the rotational velocity right off the gyroscope, I assume. And right above there's one called gyroscope calibrated. And right above that is one that says raw gyroscope. So, you know, any of those values will probably give you each individual axis as a number. Because if you ask for a vector, then you're going to have to take the vector apart to try to do anything with it. But what you really want out of it, you want the heading, and that's it's the headings under the Euler angles, and it's the, for some reason they call it the x value, which is actually the yaw value.
Well,
And the main reason I wanted rotational velocity, I was trying to compare all these different things together, because I don't know if anybody in ROS actually uses rotational velocity for anything. All the sensors report it, but I don't know if anybody actually uses that or not, which is another story about ROS, that you got a lot of more stuff than what you really need.
well, you want heading because then you go calculate rotational velocity, but I think this thing will actually calculate rotational velocity.
No, you want heading because ROS wants heading. You know, if you try to feed it into this localization stuff, it wants to know your XY location and your heading. And whether the heading, it could be, it wants heading as a quaternion or something, but the holy grail to all this, that device, you want to know what direction you're pointing. That's the main point of this, is putting this IMU on there.
No, I get it. Heading is a good thing, right? And you're getting heading off of your GPS and you're getting heading off of your IMU. But back to steering control, forget heading for a second. For steering control, not navigation, for steering control, we talked about rotational velocity, right? That's my step. I have two goals. Yes, I know I need heading. And yes, this can provide heading.
In this case, yes, you can use rotational velocity to verify that your steering calibration is correct. So yes, that would be useful to know that.
Would you get rotational velocity from linear acceleration, or would you get linear velocity from raw gyroscope or filtered gyroscope?
You wouldn't get it from linear acceleration at all, because that has nothing to do with rotation. So it's going to have to be something to do with the gyroscope to tell you that.
You don't think linear acceleration x is the equivalent of rotational velocity?
No, I don't.
Okay. Trying to get back to that table of contents.
And once you're plotting numbers, just have it plotted on the screen, you can actually just take the thing and move it, and you can see what's coming out of it and see if that's, looks like what you want.
Yeah, which is, I mean, the next thing I was going to say is I literally mounted this on a servo and was going to rotate it slowly and watch values to see.
And in fact, if you're doing this on the Arduino, once you get it so it can rotate that, then fire up the Arduino serial plotter, and you can actually watch the line move on the screen in real time.
Yeah, so that was going to be my testing process. But so back to which of these reports you think is most likely something close to you pointed to not linear acceleration. You don't think linear acceleration is?
No, I don't. I think you could look at raw gyroscope or gyroscope calibrated or gyroscope uncalibrated. Try looking at all of those and see if they're giving you what you want.
Gyroscope calibrated axis X. Yeah, that's really helpful.
So, well, Y is going to be your yaw value. That's the one you want.
You think Y is?
And this is all based, if you look on your board, they're gonna have a little thing silk screen on there showing you your X, Y, Z directions for this stuff. But generally Z is always up. So you want your Z axis is gonna show rotation. And I assume gyroscope calibrated and gyroscope uncalibrated and gyroscope raw are probably all gonna have the same format. So it's just a matter of pointing to the correct register, or as they call it, the correct report. So if you scroll up or down there and say what says gyroscope uncalibrated look exactly the same.
Raw gyroscope.
Oh, did that say, what did that say? It said future report to change the sensitivity. Oh, okay. So yeah, scroll back down, or yeah, that is right there. So again, they may be in different fields, but yeah, again, you want the Z axis on that. And they also show you, you can read the temperature there too if you need that. And if you get really carried away, you can read the temperature out of gyroscope and try to calibrate things or compensate things. But it just gives you another thing in the world that says what's your ambient temperature, because that will tell you if you really want to know.
Yeah, this device is actually a bit fascinating to me anyway, in the sense of, I mean, look at some of this stuff that, I mean, you get, I mean, it has a rotation vector.
Yeah, it's got all the stuff built right into it. And on the older ones, you had to have the external Arduino to do all this number crunching. And they've simply put a Cortex M0 processor right inside of the module. And they added all this extra software. So yeah, you fire it up and it just dumps out the values, which is why it's so amazing. You can just say, tell me the heading, and it does. And the other important thing is all the other sensors, you have to take the sensor, wire to an Arduino, and then you have to run this extensive magnetic calibration with taking the thing and rotating it around for 2 or 3 minutes to generate this sphere of magnetic points. And then you've got this big elaborate thing that says, here's your magnetic offsets. Well, this thing just does that automatically. You turn it on and you wiggle it around like this a few times, and it says, okay, I'm calibrated, ready to go. And on mine, again, since you can't wiggle it on the robot, I just strapped it down with my rubber band, pointed the thing north, and as you drive around a little bit, it says, okay, I'm ready to go. I know where I'm at now. So that's absolute magic there.
But this rotate, I mean, what it labels a rotation vector, I mean, is a quaternion. I'm like, I don't.
So it's possible that is, if you want to feed something from this into that, what do you call it, NavSat conversion node, what do they call that? That's what it wants to see, is this rotation vector as a quaternion. Normally it said, actually they might put it in as an IMU message. So you'd have to take this quaternion and put it in your IMU message, but that's probably what it wants there. So yeah, keep in mind, you got a lot of data here, and you just pick and choose the ones you want. And there's probably a lot more than what you would ever want, but it's handy that the stuff is all there and ready to go.
Yeah,
and for low level testing, like if you can read the gyroscope out directly, that can tell you things. And you could read the accelerometer out, but I'm not sure what you would actually do with the accelerometer. I'm not sure what even Ross does with it. It uses that occasionally, but I'm not sure exactly what it does. I think if you have your extended Kelman filter, it's smart enough to look at the gyroscope and say, okay, the guy is accelerating or decelerating. Or what you'll see is, if you're going to drive in a straight line, as the thing starts up, you'll see a blip like this. The thing accelerates up to speed, and then it'll stay at 0 acceleration when you stop. Then it'll go down like that. And that's the kind of stuff that comes out of the accelerometer. And that's not, people say that if you rotate the accelerometer, that due to centrifugal force, you will see some acceleration in the outward direction because you're doing that. But the gyroscope is just, it's meant to do that. So the gyroscope is what you want. If you anything to do with rotations, take it off the gyroscope. And then they mix accelerometers and gyroscopes and magnetometers together to come up with all these other vectors and headings and all this other fancy stuff that normally you had to do that on an Arduino, and you had to get the the Magic filter or the something complementary cosine filter. They have all kinds of different filters. This is just all built right into the chip and apparently is just going to work according to my plots that I just made. So
Okay, I just was, I mean, my tortured logic was, oh, they're already calculating the difference in compass heading with the linear acceleration report. That's where I was headed, but anyway, yeah, they also have the whole heading thing in here too. So
click on the one that says pressure. What is that?
yeah, they have all of this stuff. So
But I don't believe your sensor has a pressure sensor in it. So I was curious what they're telling you about that. And ambient light, I don't think it has an ambient light sensor in it either, unless this is for a specific board that they sell. They might sell you an eval board.
atmospheric pressure, my man.
That's what it says.
In hectopascals.
Uh-huh. That's a new one on me if it's got the pressure sensor and light sensor built into it, because I don't think that they do, and I'm not sure. What says just because it's in that list doesn't necessarily mean that it will do it. So keep that in mind.
Doesn't mention it here, but let's go back here.
Because typically you'll put an extra sensor on the board, like a B&O 180 or 280, or there's various chips you can use that will read barometric pressure, but typically it's an extra chip that somebody solders on the board if you really want that. And the advantage of measuring barometric pressure is you can calculate altitude from that if you know what the current barometric pressure in your area is. But if you got a GPS that's telling you your altitude, that's going to be, again, much more accurate. So
maybe it's derived pressure because yeah,
it's something to look into someday, but I'd say don't worry about it right at the moment. So
yeah, I mean, I was just
go back to the top there. The title of this document, it didn't say SH2 something.
Yeah, it was really easy to find. SH2 reference manual.
So I'm thinking SH2 is a board that they sell, not necessarily the chip itself. Because you can pull up the actual reference for the chip. So I think this is probably extra stuff on the board that if you just go out on Google and search for that SH2 board or module or whatever, I think it'll show you a board with various things soldered down to it. Is probably right there. Intended audience. Implementing product that uses SH2. And it could be SH2 is just a little tiny board that's got various sensors soldered down, and then you bolt it on, solder that down to your own product. So anyway, that's something to keep in mind.
It was a torturous journey to find this.
What I have done so far, since I started with that, or one of the things I started with was the Adafruit library. And another thing to keep in mind here, I noticed they seem to be interchangeable between the 055 and the 085, because anytime, whichever sensor, they always point to one library that seems to work on everything. So, and especially if you had the Adafruit library running on yours, which is an 085, I have it run on mine, which is 055. Yeah, I didn't have to change anything between the two. So apparently the registers are all in the same place. So if I say, give me the heading, it's going to give me the heading no matter which chip you have. So that's something else to keep in mind, that, you find examples for this stuff. Probably anything that says 055 will probably work on your chip also. And my whole point was I just went through their list of things that they're already reading and reporting on the Adafruit library. And that's where I was pulling up my reference to stuff to make it, to make the stuff work.
Yeah, I have had to be careful about which, I mean, I've had to be careful about which include statement goes with which code.
Well, my point was that the chip itself, whether it's a 55 or an 85, it internally works the same way. Now, all this I2C stuff, that's Arduino level stuff. And yeah, I see there's 3 or 4 different ways to do the I2C, which can be a problem. But the chip itself, it's got registers, and you can read out gyroscopes, accelerometers, and heading and quaternions. I think that's the same between the 2 chips, although the one you have may have the new tap function and all this other, fancier features they've added on. But I think the base level stuff is probably all the same.
And this one references even a third board, an 080, which I haven't. I don't even know what that one is all about.
If you look at the Spark or the Adafruit website, it says, oh, the 85 replaces the 080 because it had some kind of a timing problem in the SPI interface. So it's just simply a newer version that fixes something, I think. Yeah, the one you have is a slightly newer version to fix the problem that 080 had.
So,
and other than that, I don't know the history of a lot of the stuff. I just simply got it wired up and it's putting out numbers that I can use. And that gives me direction to go.
Well, if you don't mind, you might get a question or two about reading bits and bytes and converting them, because when it comes to this least significant bit and getting down to these,
that line you have highlighted is just simply taking a big number and shifting it over 8 places, so it's dividing it by 256. It moves over by 1 byte is what that's doing.
piece of cake, piece of cake.
So on a related note, if you figure out in Plotjuggler how I can divide all my points by 100,000, let me know.
I promise you, you'll be the first to know. Anyway, so that's what's going on. Anything else?
Not off the top of my head, no.
That's plenty. Well, have a good weekend. Don't blow your hand off with any M80s or.
I probably won't even go near that stuff. But for the next week or two, it's going to be going off all night.
Definitely. When is the actual 4th? Is it
Sunday, I think.
The dog will be hiding under the bed.
I assume today would be a national holiday, but I see they're out replacing gas pipes today, so apparently they don't get the day off. Or maybe they get Monday off, or maybe they don't get any days off. I don't know.
My suspicion is Monday. Have a great weekend, Jeff.
Okay, see you
Talk
later.
to you later.